Have you ever felt, well, just completely swamped by information? It feels like we're drowning in facts, figures, endless reports, especially when you try to make sense of public data. I mean, it's out there, loads of it, but it's often so fragmented, inconsistent, hard to use. Just getting a clear picture feels almost impossible sometimes. So today we're going to tackle this head on. We're diving into a really fascinating initiative designed to solve exactly this. Google's Data Commons, basically it's an open source knowledge graph. Its goal is to organize all that publicly available statistical data, and it really promises to change how we interact with public information, making these complex, messy data sets potentially as simple to navigate as, say, the internet itself. Yeah, so our mission for this deep dive is pretty clear. Give you a shortcut to understanding how this powerful system actually works. We'll look at the surprising ways it's already transforming how we access information and how it could empower pretty much anyone, researchers, policymakers, just curious citizens like you to be truly well informed and maybe even help solve some of those big societal challenges we're facing. Okay, so let's start with that common struggle, that feeling of data overload. Researchers, people making policy, or honestly, even just someone trying to understand a local issue, they spend an extraordinary amount of time just wrangling data. I remember trying this myself for a small community project, trying to pull crime stats and local economic data together. It felt like I needed a whole team and maybe a year just to get it usable.
Yeah, and I've seen those studies too, data scientists spending up to 80% of their time just cleaning, merging, managing data before they can even start analyzing it. It's like planning a fancy dinner, but spending all day just washing and chopping and then having no time left to actually cook. It's a huge bottleneck, massively inefficient.
That's exactly the pain point Data Commons is designed to address. And it's important to understand it's not just another place to download data sets. That's not the main idea. The vision is much, much bigger. It's about creating a unified view, a single source for these vast amounts of publicly available stats. Think about it like this. The long-term goal is really ambitious. It's aiming to do for public data what, say, Google Search did for the web, or what Google Maps does for getting around. Organize all that scattered information and make it genuinely accessible and useful for everyone. And this isn't just about making things easier, though it does that. It's about unlocking insights that were basically hidden before, trapped in different data silos. It empowers anyone to make the kind of data-driven decisions that used to need specialized analysts. Right, so a concrete example. Instead of you needing to dig through maybe 3 different government websites or agency reports to find population numbers, poverty rates, and unemployment figures for one specific county, Data Commons lets you pull all of that from a single source. And here's the really crucial part. It uses one unified schema, like a common language, and one API, one way to ask for the data. So what used to be this massive time-sucking job, maybe weeks of data wrangling, can become, well, minutes of just retrieving the data you need.
Okay, that sounds incredibly powerful. But how does it actually pull that off? Unifying such different information from so many places, it almost sounds like, well, magic.
Not quite magic, but it is built on some very clever technology. The foundation is a knowledge graph data model. Now, if you're familiar with graph databases or semantic web ideas, you'll get the power here immediately. For those maybe less familiar, just picture a huge network where everything's connected, not just by simple links, but by meaning. So this graph is made of nodes. These are the entities, things like cities, countries, organizations, diseases, you name it. And then you have the relationships between these nodes. These form what are called semantic triples. It's like stating a fact. Paris, node, is the capital of relationship. France, node. Simple idea, but incredibly powerful at scale. And this whole thing is built on the schema.org framework. That's a big deal because schema.org is an open standard, kind of like a universal dictionary for describing things on the web. Think of it as a blueprint that tells search engines, hey, this page is about a person, or this is an event. Data Commons uses it to define all its entities and relationships precisely. This makes all that diverse data understandable and, crucially, linkable across all the different sources. And within that graph structure, 2 key concepts you hear a lot are statistical variable. That's the precise definition of what you're measuring, like median income or CO2 emissions per capita. And then there's the observation, that's the actual value of that variable at a specific time and place, like the median income in City X in 2022 was Y dollars.
Right, that structure, that common language, must be what allows it to handle such immense scale. Because you mentioned it aggregates data from, over 200 different sources, public, reliable sources.
Exactly, over 200.
Yeah.
And we're talking the heavy hitters. The UN, U.S. Census Bureau, World Bank, Bureau of Labor Statistics, NOAA for climate data, even the FBI for crime stats. Major authoritative sources.
Wow. Sheer volume must be staggering.
It really is. It results in thousands of individual data sets being combined, which translates to, get this, over 250 billion global data points. And in terms of the knowledge graph structure itself, that's around 3.7 trillion triples those node relationship node facts. It's genuinely a universe of interconnected data.
3.7 trillion. That's hard to even picture. But with that much data coming from so many places, how do you ensure it stays accurate, consistent? Is there like a constant checking process, or does the graph structure itself help manage that?
That's a really critical question. Consistency comes from a couple of key things. First, as I mentioned, the data comes from authoritative sources. These are agencies whose job it is to collect and publish reliable data. Data Commons organizes. It doesn't create new data from scratch. Second, yes, the knowledge graph's unified schema is vital. When data from different sources, maybe using slightly different definitions or formats, gets mapped onto this single schema, it gets normalized, harmonized. This process itself helps flag inconsistencies. It forces a common structure. Now, Data Commons is always improving its ingestion, its matching algorithms, but the core integrity really relies on the quality of those original sources and that rigorous mapping to the schema. And the breadth of topics covered is also pretty amazing. It's not just economics and demographics, though there's plenty of that. Data Commons also includes really extensive data on education, housing, public health, climate, sustainability, even biomedicine. And having all that in one place allows for the kind of multidisciplinary analysis that used to be incredibly difficult, simply because the data was locked away in different domains, different formats.
Okay, so we get this huge unified knowledge graph and the structure, the sources. The next big question is, how can you, the listener, actually get your hands on this? How do you use this powerhouse? Do you need to be a hardcore data scientist?
Not at all. That's one of the best parts. There are multiple ways in, designed for different levels of technical skill. So for just exploring and maybe some quick analysis, you can go straight to the datacommons.org website. It's got a search bar, works a lot like Google search, and it has these really neat visual tools, things like the Map Explorer, Scatter Plot tool, Timeline Explorer. You could, for instance, easily pull up a world map showing life expectancy changes over the last 15 years.
Right.
Or maybe a scatter plot comparing, I don't know, heart disease rates versus temperature projections for different places.
Oh, interesting.
Yeah. Or use the timeline tool to compare something like the median age in different university towns, Berkeley, Gainesville, Cambridge, over decades. Just a few clicks, no code needed. Now, for those who do like to code or need more power, there's very robust programmatic access through APIs. There's a standard REST API, but also really useful client libraries for Python and Pandas. That Python v2 library, especially with its Pandas data frame support, that's a game changer for data scientists. Makes integrating Data Commons data into their existing workflows super smooth.
Right. Pandas is huge in data science.
Exactly. And it's so effective, it's actually being used in university courses now, like MIT's data science curriculum. Students get access to real-world, clean, harmonized data for their projects. Much better than just toy data sets. You can even query it directly using Spark Hero, which is the standard query language for knowledge graphs, if you're familiar with that.
Okay, so options for coders. What about folks who aren't?
Yeah, absolutely. For users less comfortable with code, there are some great user-friendly options. There's a Google Sheets add-on that lets you pull Data Commons data directly into a spreadsheet. You can analyze it, chart it, all within that familiar interface, zero coding required.
That's clever. People know Sheets.
Right. And there are also these things called web components. These let you embed Data Commons charts and data directly into your own website or blog. Again, making it easy to share insights without needing to be a web developer.
That really does cover a lot of ground, making it accessible, which means for you, listening, becoming genuinely well-informed on a topic, local housing, global climate, whatever, isn't just for the specialists anymore. It really democratizes access to these insights. And speaking of using it in different ways, you mentioned something fascinating. Organizations can build and host custom Data Commons instances. Tell me more about that.
Yes, that's a powerful capability for organizations, businesses, research groups. Essentially, a custom Data Commons instance is like having your own private, secure version of the Data Commons infrastructure. The huge benefit is it lets you natively join your organization's own private or specialized data with all the public data already in Data Commons, all within that same unified framework.
So you can mix your proprietary data with the public context.
Precisely. You bring your unique data sets, maybe internal sales figures, specific research results, local survey data into the Data Commons structure, and you maintain complete control over your data, your privacy, and the computing resources used. doesn't automatically go into the public graph unless you choose to share it.
Okay, so it's not necessarily a walled garden then. It uses the same structure, so interoperability is possible.
Exactly. While you control your instance, the underlying schema.org framework means it speaks the same language as the public data commons. So organizations can use it purely for internal analysis, or they could potentially contribute clean, valuable data sets back to the public graph later if they wanted to. It facilitates both private use and potential public contribution. It's really a way for organizations to leverage this powerful framework for their own specific needs, maybe even customizing the interface. And we're already seeing major partners doing this, folks like the United Nations or the One Campaign. They're using custom instances to integrate their specific program data maybe on progress towards sustainable development goals, or tracking economic opportunity initiatives with the broader public context in data commons. This helps them get much more tailored, actionable insights for their specific missions.
That makes sense. Okay, so we have this vast data resource, multiple ways to access it, even custom instances. But this raises another key question. With all this complexity, even with the visual tools and Sheets add-on, how do we make it truly intuitive for everyone? How does it become a tool for the average person asking a question without them needing to learn SparQL or even how to structure a complex search?
Right. That's the next frontier, and it's where the natural language interface comes into play. This is powered by, you guessed it, large language models, LLMs. What this means is you can basically ask data commons questions in plain conversational English, just like you'd ask a colleague or an expert. You could ask something complex like, which states in India have the highest poverty levels per capita?
Okay.
And then you could follow up naturally, maybe asking, okay, how do literacy rates compare to poverty in those specific states? Or you could ask comparative questions across regions, like compare greenhouse gas emissions from agriculture in Europe versus their GDP. You just ask, and the system works to get you factual answers.
But wait, LLMs, aren't they known for sometimes, well, making things up? Hallucinating. How does data commons avoid that, especially when we need factual answers from data?
That is the critical concern, and data commons is designed specifically to address it. Here's how it works. The LLM is used to understand the meaning of your natural language question. It translates your plain English into a query that the data commons knowledge graph can understand. But, and this is key, the LLM doesn't generate the answer itself from its own training data. Instead, the results are retrieved directly from the structured data within data commons.
So the LLM is like a translator, not the source of the facts.
Exactly. It figures out what you're asking for, then fetches the actual data points from the graph. And crucially, the system provides links back to the original source data for those facts. So you get transparency, you can verify the information yourself, it ensures factuality and builds trust. The LLM facilitates access, but the graph provides the grounded truth.
That makes a huge difference, grounding the AI in verified data.
Yes. And to push this grounding even further, Google's been experimenting with open models called Data Gemma. Think of Data Gemma as adding extra layers of fact-checking for the LLM when it interacts with data commons. It uses techniques like retrieval interleaved generation error. That's kind of like the LLM constantly checking its work against the data commons data while it's figuring out the answer, double-checking as it goes. And another technique called retrieval augmented generation, or RAG. That's more like giving the LLM a cheat sheet of relevant facts from data commons before it even starts generating the response, building the answer on a solid factual foundation.
So RG checks during, RG provides facts before. Got it.
Right. Especially with powerful models like Gemini 1.5 Pro that can handle huge amounts of context, you can feed the LLM a lot of relevant data commons info using RAG, allowing for really deep fact-based analysis from a simple natural language question. It's about making AI trustworthy for data exploration.
Okay, this is all incredibly impressive technologically, but let's bring it back down to earth. What does this all mean for actually solving real-world problems? How does this help you or your community make a tangible difference? This is where Data Commons needs to deliver on that promise of being a shortcut to being well-informed in a way that leads to action, right?
Absolutely. That's the ultimate goal. And the real power here, I think, lies in the integrative nature of Data Commons. Because it consolidates all this diverse information, it makes it incredibly easy to join data sets that used to live in completely separate worlds, things that were historically siloed. This ability to connect the dots, to see relationships across different domains, health and climate, economics and education, that's what leads to deeper understanding and hopefully more effective solutions. It reveals connections previously hidden by just how fragmented data was.
Can you give us some examples of that in action?
Sure. A really compelling one is Feeding America. They're the big nonprofit fighting hunger in the U.S. They use data commons to combine their own key metric, the Meal Gap Index, which measures food insecurity county by county with climate change data, like temperature projections from the IPCC.
Okay, food insecurity and climate change, not data you'd usually find in the same place easily.
Exactly. Before data commons, their analysts might have spent weeks, maybe months, just trying to find, clean, and align these completely different data sets, dealing with different formats, different geographical boundaries, data gaps, a nightmare. Now, using data commons, they could do this comparison in minutes. They can easily overlay climate risk onto food insecurity maps. So they can quickly identify, for example, which agricultural counties in California are projected to face the most severe temperature increases and already have high rates of food insecurity.
Ah, so pinpointing the most vulnerable spots where multiple crises intersect.
Precisely. They found many of these high-risk counties are agricultural hubs, acting like canaries in the coal mine for climate impacts on food production and access. This lets Feeding America target their resources and advocacy much more effectively.
Yeah.
It's a huge leap from tedious data wrangling to strategic insight.
That's a powerful example. Any others?
Yeah, another great one is TechSoup. They work to help smaller nonprofits get access to technology and data expertise they often can't afford on their own. TechSoup uses data commons to help these local organizations combine climate data with all sorts of other relevant local information, things like health outcomes, job statistics, poverty rates, even the locations of nearby social service providers. And they can often do this down to the census tract level, really granular detail.
Wow, that level of local detail must be incredibly valuable for community organizations.
It really is. It gives them insights that were pretty much unattainable before. Marnie Webb, who's the Chief Community Impact Officer at TechSoup, put it perfectly. She said it's about the democratization of information for better decision-making, so that organizations can take smart risks to better serve their communities. It puts sophisticated data analysis capabilities into the hands of the people who know their communities best, allowing for much more targeted and effective interventions.
Democratization of information for smarter risks. I like that.
It really captures the potential, doesn't it? Bridging that gap between abstract data and making a real difference on the ground.
Now, having said all that, it's important to be realistic. Data commons is amazing, but it's still a work in progress. The data coverage is very strong, particularly for the US and other OECD countries, but there are definitely still gaps, especially in parts of the global south where reliable, standardized public data can just be harder to come by. So there's an ongoing need for more partners, more community contributions to help expand that global coverage and fill in those data dark spots, making sure the benefits reach everywhere.
That's a fair point. It's a massive undertaking, and building truly global coverage takes time and collaboration. But what an incredible exploration this has been. It's really clear that Data Commons is aiming for something transformative, turning that chaotic, messy sea of public data into something organized, interconnected, and crucially, accessible. It really is like taking a dusty, uncatalogued library and turning it into this perfectly indexed digital archive where everything is linked, making complex research feel almost intuitive.
That's a great analogy. And the ultimate vision, the driving force behind it, is empowerment. Empowering more individuals, more organizations to use data effectively for the critical decisions they face, helping us all collectively tackle huge challenges like climate change or food security or social inequity with much greater clarity and efficiency. It's about making complex data truly actionable, moving beyond just numbers on a page to real, meaningful insights.
So here's a final thought to leave you with. Imagine the discoveries we could make, the problems we could untangle, if every piece of public data was as connected and as easy to explore as the web itself. What questions would you ask, knowing you could potentially get factual, grounded answers from unified knowledge graph like Data Commons? What would you want to know?